Hey, this is Stephen Ament. Welcome to my Exorcism.io series. In this episode, I will be working through the Hamming exercise. What we are supposed to do in this exercise is to calculate the Hamming distance between two DNA strands, and that's found by comparing two strands, comparing each of the nucleotide pairs across the strands, and counting each spot where there is a difference. So in this case, the Hamming distance between these two strands is 7. There's a note here that the Hamming distance is only defined for sequences of equal length. So what we're going to do in our case is raise an exception if the strands are not equal. All right, test will fail because we have no file hamming.rb. Define our class. And I notice that this does not use an initializer. So the failure here is because we have no class method compute. So let's define compute. And this is going to fail because the wrong number of arguments. It takes 2, which I will call strand 1 and strand 2 because we're comparing two DNA strands. And this is going to fail because we're returning nil, and our first test is expecting a 0. Let's just return a 0. All right, there we go. First test passing. Let's go ahead and run our second test. It's also 2 equal strings. The first test was 2 empty strings. The second test is 2 equal strings. This is also going to pass. So our next test single letter with different strands, is going to be our next failure. So now we actually have to do some work. What are we going to do? What's the simplest thing we can do to get these to work? If strand 1 is equal to strand 2, then we want a 0, otherwise a 1. That'll get us there, but it's not gonna work here. Oh, it is gonna work there. Okay. It's not gonna work here though, because we don't just want to return a 1 if it fails. We actually want to get the distance between them. So, okay. So what do we got to do? So what we need to do is to compare each character and count up the number of characters that are different between them. So there's, sort of a Ruby-ish way we can do this from what we learned before. Let's take strand 1 and use that as our basis. We're going to split it on an empty string so that each character will be its own element in the array. And then we're going to look at each with index. The reason we want the index is so that we can look into the same spot in strand 2. So what I have here is a char, and I have an index. And so what I'm going to want to do here is build up a count. Let's start it at 0, and let's return at the end. And so count, I'm going to increment if char is not equal to strand 2 index. All right, so that's going to get us past that test. Our next test is going to fail because it's expecting an argument error for strands of different lengths. Let's just go ahead and raise that. Unless strand 1 dot length is equal to strand 2 dot length. And then our final test should pass as well. Okay, let's go ahead and push this up as our first solution. But I look at this. I think this can be a little bit better. There's a couple of things going on here that I think we can do a little bit more easily in Ruby. And I'll tell you, the first thing I don't like about this, one is I feel like by initializing this to count here and then returning count down here, I just have this sense that there's something I can do within this block here to actually build up that count and return it. And so what could we do with something like that? Well, let's see. Each with index. What would reduce give us here? If I initialize it to 0, I think what I might get is my counter or accumulator, as well as an array for my char and my index. Is that what I've got? And so in this case, I want to return counter plus equals 1. Let's just see if that does what I expect it to. No, it explodes because, let's see, that syntax doesn't work there. What I'm trying to do here. So what have I got? Counter and my strand or char with index, which we can split out into char, index, char with index. Undefined method plus equals 1 for a nil class. Really? Let's require pry, binding.pry. Something is not doing what I expect. Counter is nil. Counter is 0. Char with index. Yeah. So this is doing what I think. Let's go to the next one here and continue on. Okay, it's working. Okay, here counter is nil. What's our strand 1? Why is that nil? A and 2. The counter should have been initialized. Oh, I got it. You have to return something, or your accumulator will become nil. So what I want to do is, if char is not equal to strand to index, then I just want to return counter. Otherwise, I want to return counter plus equals 1, or counter plus 1. Of course, I don't want to do that. Move the pry. Does this have to be a plus equal 1? No. So what's going on here? Oh, it's the opposite. It's the opposite. I want to count it if they're not the same. Otherwise, I just want to return the counter. There we go. Okay. So this works, and it keeps me from having to initialize that counter and do that separately, right, from everything else. But I think there might actually be another way here, and it's something that I let's see. What bugs me is that this comparison here that's happening is the sides of this are not parallel, right? Over here I have something called char, and over here I have strand 2, and I'm indexing in to whatever character in that string. Those are not balanced. The sides of that are not balanced. So just visually, it's more work for me to understand what's happening there. Also having it in a ternary here, which I generally like ternaries, but it's just it's a little messy. I don't like this, so I actually want to take another approach here and just see what I can come up with. Normally in Ruby we don't like to have counters and loops and things like that, but in this case I think it might be what we need. But instead of initializing a counter like this and doing a while loop, I'm going to do take advantage of a method on the integer class called up_to. What up_to does is it iterates from the integer that you started with up to the limit that you pass it. So it's sort of like a for block in other languages. Up to strand 1 dot length is going to be our limit. So I'm going to go up to those and replace the beginning of this. Oh, wait a second. That's not even it. Let's see what happens if I do this. I think what this is going to give me is my counter and then my index. And what this will allow me to do is, instead of that comparison, compare a strand 1 index to strand 2 index and then build up my counter that way. Yeah, that actually works. But there's something that I want to try instead of that reduce. The reduce in this case, we always have to return something. But enumerable here has, let's see, is it enumerable? Is this what I'm looking for? Yeah, enumerable has a method called count that will return the number of items in the enumerator that match the block. So count in general, right? You can just count the items, and that's going to give you the number of items that you have altogether, right? 0 up to strand 1 dot length count. That's just going to tell you how many of those are. If you pass in 7 items to strand 1 dot length, your count's going to be 7. But you can give count a block. And in that case, there's no counter. We still have our index, right, from this count here. But instead of needing that ternary, we're just returning the conditions under which we want each item to be counted. So in this case, we want index to be counted if the element in that position in strand 1 does not match the element in that position in strand 2. And that's going to be our count. And I like this. Even though I don't normally like looping a certain number of times and doing things, what I like about this versus the version we had before is I can look at this and the sides of this comparison are balanced. I have the same sort of thing on the left as I have on the right. It's very clear to me that I see strand 1 index on the left and I see strand 2 index on the right, and I get it. I get what's happening there, what I'm checking. And because this is count, I know count, we use count all the time, but we're not used to thinking about passing count a block to do something with or something like that. So that's the only part of this that's a little confusing. And as you can see, like I went and actually looked it up as if it were not the same count that we use all the time just for counting elements in an array, right? And that illustrates the point a little bit that this is behavior or functionality that we're not used to seeing, but turns out is actually really, really useful. So this is, I think, where I want to be. I don't know really what else I would do here. I think this is pretty complete. I'm going to go ahead and submit this. And I think I'm going to call it done.